Hello students, today I am going to start the chapter Some Applications of Trigonometry. This is the 9th chapter of your course, and in application of some trigonometry, your chapter is height and distances. Height and distances. Heights and distances. Okay. Now you see. Suppose you see an object. This is your eye position. Suppose the eye position. Eye position of observers eye, and this is the object. Suppose object. If you see, this level is called horizontal level. Okay. So this is the eye, the object, and the eye position. If you see the straight way, this is called horizontal level, and if you see the object in this direction, this is the horizontal direction, then this angle made by the horizontal level with the line of sight, this is called line of sight. This is called angle of elevation. Angle of elevation. Okay. If you saw an object below the horizontal line, suppose this object is above the horizontal line, this object is above the horizontal line level, and this is the suppose object below the horizontal level. So this is the direction of line of sight. This is also line of sight. And this angle made by the horizontal level with the line of sight of the object situated at the below the horizontal line is called angle of depression. Is called angle of depression. Now you write the line of sight. The line of sight is the line drawn from the eye of an observer to the point in the object by the observer. Okay, line of sight. Line of sight. Line of sight is called. Line of sight is the line drawn from the eye of an observer to the point in the object by the observer. Now, the angle of elevation of the point viewed is the angle formed by the line of sight with the horizontal when the point being viewed is when the point being viewed is above the horizontal level. Similarly, the angle of depression of a point on the object being viewed is the angle formed by the line of sight with the horizontal when the point is below that means object below the horizontal level. Okay. Now see the problems. Now discuss the problems. The first problem is exercise 9.1. 9.1. The first problem is a circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Suppose this is the pole and tied. This is the rope. A circus artist is climbing a 20-meter long rope. The 20 meter long rope. So AB is C. AB with the pole is the rope. AC with the rope, which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degrees. This angle is 30 degrees. This is the pole, and this is the rope. The pole. You have to find the pole, and this rope is tightly stretched with the ground. You see AC with the rope of 20 meter, and you have to find the height of the pole. So question number 1. Let AB be the rope pole. AB be the pole. AC equal to 20 meter be the length of rope. Be the length of rope. And angle BCA equal to 30 degrees. In right triangle ABC, AB by AC equal to what? Perpendicular by hypotenuse, that is equal to sine of 30 degree. So AB is AB, AC is what? 20 equal to 1 by 2. That is AB equal to 1 by 2 into 20 implies AB equal to 10. Hence, the height of the pole is 10 meter. This is the answer. Okay. So next problem. Next problem C. A tree breaks due to storm and broken part bends so that the top of the tree touches the ground. Make an angle of 30 degrees with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Find the height of the tree. Now see. the ground level. Ground level, and broke the T here. Suppose this is B, D, A. Or D, A. This point is suppose C. This one is 8 meter. This angle is 30 degree. Suppose you take this one equal to H1 and this one equal to H2. H2. And this portion and this portion are same. This one is again H2. And broken part, this is a broken part. This portion and this portion are equal. H2. H2. Number 2. Let BD be the length of tree before the storm. Before the storm. After the storm, AD equal to AC equal to length of the broken part. Length of the broken part of the tree. Also, angle ACB equal to 30 degree is given. Let BA equal to H. So this is H2. This is H1. And AD equal to H2. In right triangle ABC, AB by BC, AB by BC equal to what? Perpendicular by base equal to tan of 30 degree. And BC is already given, so implies AB is what? H1 by 8 equal to 1 by root 3. 1 by root 3 implies H1 equal to 8 by root 3. Implies 8 root 3 by 3. Root 3 multiply denominator by numerator by root 3. 8 root 3. Number 1. And AC by BC equal to what? Sec of 30 degree. Convert hypotenuse by base to sec of 30 degree. So AC equal to what? H2. And BC is what? 8 equals sec 30 is 2 by root 3. Implies H2 equal to 16 by root 3, then 16 root 3 by 3. Number 2. Let's see H1, H2. Adding 1 and 2, we have H1 plus H2 equal to 8 root 3 by 3 plus 16 root 3 by 3. That is equal to 24 root 3. And what is H1 and H2? H1 plus H2 equal to what? BD. Implies BD equal to what? 8 root 3. Hence, the height of the tree, is 8 root 3 meter. This is the answer. Next, question number 3. A contractor plans to install 2 slides for the children to play in the park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter, is inclined to an angle of 30 degrees to the ground. Whereas the elder children, she wants to have a steep slide at a height of 3 meter, inclined at an angle of 60 degrees to the ground. What should be the length of the slide in each case? Okay. Slide again. You have to draw 2 slides. Suppose this is one slide below the age of 5 years. See, suppose it is L1 length and it is 30 degree. Height is what? 1.5 meter. Slide. This is a slide. Okay. Number 3, case 1. For children below 5 years. Children below 5 years. 5 years. Let AC equal to L1 L1 meter be the slide and BC equal to 1.5 meter, the height of the slide, height of the slide. And angle BAC equal to 30 degree. In right triangle ABC, BC by AC equal to BC by AC, that is sine 30 degree, implies BC is 1.5 by AC equal to 1 by 2, implies so AC is what? L1, AC is L1, so L1 equal to 2 into 1.5, so L1 equal to 3. Hence, the length of the slide is 3 meter. For children below 5 years. And case 2, for children, elder children. For elder children. Elder children, diagram is changed. ABC, L2 meter, and this angle is 60 degree, the slide. This one is 3 meter. Let AC equal to L2 meter be the slide, and BC equal to 3 meter the height of the slide and angle BAC equal to 60 degree. In right triangle ABC, BC by AC equal to sine of 60 degree. that is BC is 3 L2 equal to root 3 by 2, implies root 3 L2 equal to 6. So the L2 equal to 6 by root 3. That is 6 root 3 by 3, that is 2 root 3. Hence, length of the slide is 2 root 3 meter. 2 root 3 meter. Okay. This is question number 3 answer. So next class I'll discuss from question number 4. Today I stop here. Thank you.